Hello student, welcome to my mathematics corner. I am Mukul Sarma, subject teacher. Today I shall discuss some problem. This is in the exercise number miscellaneous exercise in chapter 2, and I shall discuss three important problem which is important for the examination point of view. So at first this problem is fx is equal to x square 2x plus 1, x square minus 8x plus 12. We have to find domain. That is, how can we solve it? Solution. We know that 0 by 0 and something by 0 is not defined. Therefore, fx will be real. Fx will be real if x square minus 8x plus 12 is not equal to 0. Because if x square minus 8x plus 12 is equal to 0, then it will form form like this something. This is form like this. So it is not defined. It is not defined. So this portion, the denominator of the function must be not equal to 0. So fx, therefore we can write fx will be real if x square minus 8x plus 12 not equal to 0. Now we solve it by factorization. X square minus 12, 6 plus 2, it is, this implies x square 6x minus 2x plus 12 not equal to 0. This implies x, if we take x common, x minus 6, 2 x minus 6 not equal to 0. This implies x minus 6, x minus 2 not equal to 0. Therefore we can write x minus 6 not equal to 0, x minus 2 not equal to 0. Therefore x not equal to 6, x not equal to 2. So domain is equal to real number but not 2 and 6. Domain is real number minus 2, 6. This is all of the problem number 1 I have discussed. Next problem I discuss fx is equal to x minus 1. Find domain and range. At first we shall find domain. Find domain. If we see the function, we see that there is a root of function. Fx must be real if this portion will be positive, and fx will not be real. Fx will not real if x minus 1 is negative. So we can write fx will be real if x minus 1 greater than equal to 0. Because if x minus 1 is less than 0, then fx is not a real number, it will be imaginary number. So to get the value of fx real, x minus 1 must greater or equal to 0. This implies x greater than equal to 1. So domain, the value of x is greater than equal to 1. We can write it 1 to infinity. It is as interval. 1 is included, so it is closed interval. this is domain is this. To find range, let y is equal to fx. This implies we can write y is equal to fx, means that's x minus 1 root over. Now we remove the root over sign, that is y square is equal to x minus 1 by squaring, that is x minus 1 is equal to y square. From this we have to find the value of x. X is equal to y square plus 1. But domain is, but value of x is given, but x greater than equal to 1 we have got that x greater than equal to 1. So since y square plus 1 is equal to x, therefore y square plus 1 also greater than equal. This implies y square greater than equal 1 minus 1. This implies y square greater than equal 0. This implies y greater than equal 0. So range is 0 greater than 0. So 0 to up to infinity. It is equals in, therefore close interval. This is close. This is open. This is all about the problem number 2. Now I discuss third problem, which is also most important for the examination point of view. Here fx is equal to x minus 1. Find domain and range. At first, domain. Here we have achieved that fx is equal to modulus of x. Here for every value of x there will be a value of fx. Therefore for every real value of x there is a real value of fx. We can write it for every real value of x there will be a real value of fx, because we can write it as fx is equal to x minus 1 if x greater than x, if x minus 1 greater than equal to 0. We divide it into two parts, x minus 1 if x minus 1 less than 0. This implies x greater than equal 1. This implies x greater less than 1. So for every real value of x, greater than 1 or less than 1, greater than equal to 1 or less than, there will be a real value of fx. So domain is R. Now we shall find range. To find range, there are two cases. Case 1, if x minus 1 greater than equal to 0, that is x greater than equal to 1. This is the condition. This condition is, let y is equal to fx. This implies y is equal to value of fx. We write this. We take this condition. So value of fx is x minus 1. This implies x minus 1 is equal to y. This implies x is equal to y plus 1. But x greater than equal 1, this condition. So y plus 1 also greater than equal 1. This implies y greater than equal 1 minus 1 This is y greater than equal 0. This is the from the case 1. Now case 2. From case 2, if x minus 1 less than 0, that is x less than 1. See, in this case also let y is equal to fx. This implies y is equal to, now we take the value this minus x minus 1. This implies y is equal to minus x plus 1. This implies x is equal to 1 minus y. But here x less than 1. This is the condition. So 1 minus y also less than 1. This implies, can write minus y less than 1 minus 1, minus y less than 0. This implies y greater than 0. It is the properties of inequality. Minus y less than 0 means y greater than 0. This is 2. This is 1. From 1 and 2 we get. From 1 and 2. From 1 and 2 we get, what we get? Y greater than equal to 0. 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 So we write y greater than equal to 0. Therefore range is equal to 0 to infinity. This is greater than equal, so it is close, and this is open. This is all about the solution of the problem. Next class I shall discuss about trigonometric function.